We are going to examine the magnetic fields around our reactors which are running. So let's have a look how they behave magnetically. To do this, I will use this affordable device, your mobile phone, with 3-axis Hall magnetometer, and this application which shows you the current value of magnitude of magnetic induction B vector, and this blue arrow shows the strength, the magnetic field induction magnitude and direction, as well as a vector. So we can go to our systems and have a look how it looks near them. So outside of the systems we have around 50 microtesla magnitude of magnetic field induction. So let's visit Ivan's reactor and see what we get. So we are approaching the system, and we get higher fields. Let's try from another side. It flows in. But now let's check what is the value near the motor. Here we have motor inside, so you can see we don't see the fluctuations with this application, but we will check them later with the graph of real-time fields. So going on top, the fields move. They are pointing towards the chamber. The north pole of the magnetic field is where the arrow points at. Last time we have seen polarity change on this reactor, so let's have a look if we get it today. We need some intervention from outside, so let's try our hand. we see no change. Now John is trying to influence our system. And it is quite steady. So today we don't have the effect of polarity switch, so maybe later. Let's go on towards other reactors.
It's no longer curved.
This reactor is John's one. It's tough?
Yeah, but now it's. I saw it a few minutes ago. I saw that my amp.
So it seems that this reactor's motor has stopped.
The amps went up, so I said, what's happening? It doubled.
We can check it. Okay, let's check it with just to show people how we can check it also with these magnetic detectors. So we can use another application which measures
So that has not been
the fields in X, Y, Z direction and the total strength.
But it has a cooling.
So if we put this near the motor, we should see the periodic changes, and we don't see them. That means the motor is blocked. I will show you the difference with John's system. When we put this near the motor, what we get? What we get? Well, this is the magnet of motor. So if we put it here, we don't see it. On top, but where we have seen it. Okay, let's try another motor. This one of our Arman and Marek system, so mine and Arman system. Let's check the motor. Let's put it here on top. And we can see these changes. I will magnify them. Well, last time we checked them, it was much better to see the periodicity of the rotational fields of the motor, but this time okay, let's check what is the field difference near the chamber. Okay, now we can clearly see this periodicity. Let's go more on the top of the chamber. And this periodicity reduces. So there is change. Let's go further. Let's go on the top. Now let's try another application with the arrow. And let's check the system again. So we are on the top where fields go.
So how much is it
In this way.
how much is it to charge for a hole? €1.
So at this point we see the center of the fields going towards the chamber. So this seems like a south pole of the plasma system. And the field magnitude is lower than the background field, which was around 50 microtesla. Now we are at 10 microtesla. Let's go more down. To see what happens. Now we are at the equator. Can you see what happens? It's very nice wobbling effect. At the bottom this doesn't happen. So the field is oscillating quite strongly, as you can see. We have nice rotating magnetic fields here. Come and have a look.
That is strange.
So something is happening there inside. When I go on the top or bottom, I don't see it. When I go in the middle, I see this rotation of fields.
That's because of the center pole.
Maybe. John says it's because of the center pole.
No, you see, it goes and then it shrinks and goes
And it
shrinks. And
it flips.
It's interference between center and outer core. The field is created by center core and
Let's have a look how it behaves from different side. Oh, okay. Let's continue.
it just destroyed the phone.
No. Now we see something similar. Something. Oh, now we are stuck. Okay, now we continue the rotation. Let's map it from two sides.
I have no variation.
John has no variation, so
But I have the measurement.
It's about the same.
can I move there, John, just to have a look? So what does your phone do? That's
Now it's stable.
now it vibrates.
Can you do it a little bit higher, a little bit lower? Because this.
Oh, so
It's another sensor. It's another cell phone.
another cell phone, another sensor. So
These are the magnets. There you cover the magnets.
so you see,
Oh, yeah, there are the magnets.
There are the magnets. That's something.
the magnets are rotating just inside this rotor. There are two ring magnets, or
2 and 2.
2 and 2, yeah, 4. So it's strange because I have seen this wobbling effect on my device, which is quite well visible. I will just turn it to see the values. And now I no longer see this effect. So
Wait, now I'll switch them.
but John, yours, yes, okay, switch on. Oh, but you are at 400 and I am at 30. Something strange happens here. The rotation on my magnetometer continues.
There's a problem with the.
I'm just at the equator. And now the rotation is not occurring again.
Yes, okay.
Somehow it was stuck.
It was stuck. Nine.
It's
And Jones?
you have different sensitivity also.
Yeah, there are different modes when you use this red button.
Well, I don't know how it works anyway.
You can get something like relative fields. So these are absolute fields. We can add this compass thingy. And here we have perpendicularity arrow from accelerometer, which is red, and the blue one is magnetic field.
Let's go over there to see what direction. There is a change in direction. Is this normally going to the computer? Yeah, the sound is the sound. I have to need now to make that. But like if you are so close to the reactor, you are moving. What direction is it pointed?
So we are near the motor now. The motor is running here. And we can see the changes. When we are just at the motor, you can see what happens. So that's it. Let's check again this side. And go around. And from another side, you see some wobbling. So let's check the central reactor. When we get closer to the chamber. Now this motor is running. This is the only motor, this bottom one, running the system now. These motors are not under the power. They don't consume electricity. So let's move around.
it's going down that way. You have something.
So I think this is, as you said, this is not the motor that stopped in 200 or something.
So I see now some saturation because when I move,
Can you put the conversion to this? Well, if it shows it, it will probably be worse.
we don't know yet how reliable this detector is. But as we can see, the arrow is somehow stuck. So what about this Iranian reactor? The motor is at the bottom part. And on the top part. We see similar wobbling as in this reactor. So let's check it from another side. On the top part. From the top.
Try mine again. We had a reading between 100, 120 up to 200 close to my reactor.
I will try. Well, there is some. Okay. As you can see.
This is something similar here. Very stable. If we go to this side.
When we go further, let's go out of the systems to see what will be the change.
This was.
Well, they're really far in for the sensitivity.
So now we are back at around 50 microtesla level, but so this shows magnetic field of the Earth. Let's just try to turn it. So now it behaves quite well, but when we bring it near the
If you can also measure
Evans,
measured more than 100 here. Yeah. Oops. Oh my God. It even went up to 200 at some point.
so we are at around 90, 80.
I'm going to turn this one around to see what happens.
Well, let's start.
This one doesn't have this problem.
This seems to be stable, but
Yeah, very stable. Oops.
but on those systems it's not so
Now it-
stable.
Now it's flipped around all of a sudden because I touched it probably. I touched it.
It flipped.
Yeah, I touched it. In this case, don't touch it. I touched it.
Don't touch it. I
The
touched
moment
it.
I touched it, it changed.
You were filming.
Yes. So there was some polarity change on the Evans again.
I think just by touching it, I released the field. That's Mr. Consistent.
Just by touching the reactor, we have changed the polarity. Touching what?
I touched it here by accident.
This?
Yeah.
So let's try again. What happens?
Right. I'll do it here.
Just okay. So let's try by touching.
No,
Now
nothing.
we get no feedback. Touching here. No feedback.
But the fact is, look, it's at 100. So, and it's constant.
So something happened.
But the motor stopped actually. I think the field locked to the motor.
Okay, that's it for now. Now it's stuck
Seems
on
to be
the
stuck
device.
now.
So there is some saturation.
The field locked to the device.
We have locked the mobile phone by plasmatic fields. So let's try to unblock, rotate it. If we get some change.
Yeah, okay. We're back in. It's back. It's back the way it was earlier.
So now we have flip again.
Apparently, yeah. It's flipped again.
Seems like quality change again, but
I slowly move to the other side. It points down.
keep it on top.
It's a very strong field. None of the others has that.
Yes. Okay, so that's it for now.
What? I'll switch off the